Yeah, how are you?
I'm good. How are you?
Yeah, I'm good. Last time also you came and you left, no? Okay.
Yes, yes. There was one physical meeting was also ongoing, so I left there.
Okay. Another meeting is going on.
Yeah, yes, yes.
Uh, okay. Can you please introduce yourself because our other members also will aware about you.
Yeah. So my name is Safan Flange. I am having a 5.5 years of experience in the static equipment design,
Mm-hmm.
mainly the heat exchanger, pressure vessel, and reactors.
Okay. So total is around 6 years experience, right?
5.5, 5.5.
5.5. Okay.
Yeah.
So you have any particular issues to discuss?
Not now.
Okay, Abhishek Nag, you want to ask something? You raised some your hand.
Hello.
Yeah,
Yeah.
Abhishek.
Hi.
Yeah.
Yeah. Good evening to all the team members. And first of all, I would love to thank you, Sri Ashan Tech, for having me in this group. Uh,
Well,
just to give you a quick introduction about myself.
yeah.
I'm Abhishek Nanded, consultant EPC contractor. My question is in that regarding the nozzle loads. We are facing one problem and situation here. In one of the equipment, regarding the nozzle loads.
Okay.
I'll split my questions into two. First of all, whether we have to do, first of all, what is the difference between WRC 107 and WRC 297? And do we have to do both the calculations as a mandatory whenever we are designing the pressure vessels or static equipment? Second, in case the piping load is very high,
Okay.
which the equipment nozzle cannot take, then in such case, how to mitigate such problem? Because piping people are saying that we cannot reduce our load. Yes, static equipment vendor is saying that even we cannot increase our load. So this is the situation which is going on at present, what I am facing. But sir, first my question is WRC 107 and WRC 297. Definitely. And we have to do it every time.
Yeah. Anybody in this group want to answer this his query?
Yeah.
Yeah.
Right.
Yeah,
Yes.
Ramakrishna.
So, see, we need to analyze, so we need some kind of a methodology to analyze the vessel. What is the stresses induced because of external loads, correct? So we need to have some kind of a methodology. So the available methodology is WRC 107 and WRC 297. Okay.
Yeah.
Yeah, it is mandatory to check as per WRC 297 or 107, or alternately we have another method which is called PD 5500. So these three options are available. Now in this, which one is you're asking? 297 is mandatory and all, no? So for the, it actually depends on the specification, but if it is on the shell, I strongly recommend that you check as per WRC 297. So, and for the heads, you can go with WRC 107 because WRC 297 cannot be, it is not applicable. There are no rules applicable on the head. So, you need to, I strongly recommend, and as per WRC 297, you should go with.
Okay.
Did I answer your query, not?
Yeah, just I will
Yeah.
add in this one. Like Ramakrishna told that WRC 297, it will be applicable for shell type, means cylindrical type of analysis.
Yes.
And for this 107, WRC 107, you can analyze using a lifting lug or any other type shapes also you can analyze.
Correct.
Yeah. And second question is his question is that the loads, right, Abhishek? There is loads on the nozzles.
Yeah. coming to the loads, if loads are high, you can, so the piping people are saying that it cannot be reduced, right?
Correct, yes.
So, you can try one of these methods. So, first, whatever the loads they are giving. So, whether they were given, there will be three types of loads which will come from piping. One is sustained loads, and then there will be occasional loads and thermal loads, right?
Three forces in three effects.
So that those loads, if you input in the, instead of putting all, what were you doing? Are you combining all and putting in sustained load? Is that what you are?
Yes.
But if you do that, so your design will be more conservative. First, you try and put all the loads like what they have done it. So if you do that now, so for the occasional loads and the expansion loads, you will, code allows for a more allowable stress. So then you may get you can get a bit of a relaxation there. So that you can try, okay. And the second method is you can do the analysis in Nozzle Pro. Okay.
All right.
So even after trying these two methods, it is not passing. Then you can try to give an insert plate. Insert plate. That is a locally you need to thicken the shell. That how many?
Like RF.
What is the diameter of the vessel?
It's 1.3 meter.
And what is the nozzle size you are talking about?
Nozzle size is around 8 inch.
Okay. Yeah, so you can put an insert plate. Generally, what is the thickness you are getting of the shell?
Around 8 mm.
Okay, so usually the insert plate thickness will be double. So you can put a thickness of 16 mm insert plate locally. So with these things you generally get generally.
So insert plate, you mean to say I have to provide a reinforcement pad to the nozzle?
No.
Yeah, it's similar to a reinforcement pad, but it's only the thicker on that portion. Means it will be direct. It's a replacement of the shell part around the nozzle.
So actually it will be like what Ravi said. It is similar, but it is not. What you will do, you will cut the shell. Okay. There you this pad will be directly butt welded to the shell. You will make an opening and you will put it.
Anyway, thank you.
Yeah.
Now going back to the first question.
Yes.
Okay, now it is clear that 297.
Yes.
It is for the cylindrical part,
Shell.
cylindrical component.
Yeah, correct.
Shell. So nozzles coming on the shell.
Yeah, right. Exactly.
Right.
Yes.
Now for the heads, nozzles coming on to the head.
Yeah.
For that we have to go with the WRC 107.
Yeah,
correct?
because you don't have any option, because WRC 297 is not meant for that. They have not done the study for spherical shapes. Yes.
Right. So regarding the second one, I'll try to put the insert plate.
Yeah.
And let me see whether we can do it. Okay. Thank you.
Yeah.
Okay. Any other issue you want to discuss, Abhishek?
Yeah, I have one more query regarding this derating of flange. So basically, derating UG-44. It is non-mandatory, but still, suppose flange says that you have to do derated of the flange. It means that the external loads which is coming onto the flange, we have to do the study of that flange. Like what we do for the nozzles, we have to UG-44 calls for flange. Is it correct to check for the external load?
Group, anybody answer? Because this I think several times we discussed in the group. Okay, anybody? You want to answer?
Yes, yeah, you're right. You have to derate the flange. It's generally applicable for the standard flanges because they are specified for certain rating without any external load taken into account. So when you have nozzle loads, so you have to do the derating of those standard flanges.
Okay, because in one of the case it happened, the flange rating got increased from 150, it goes to around 300, somewhere 600.
Yeah, for
It was surprised.
generally for 8-inch and below, it most definitely will increase. But above, there are slight chances of increasing. How big was your nozzle actually?
The nozzle sizes are varying. The nozzle sizes are is of various conveys, like it is around for 2 inch, then 4 inch.
2-inch will definitely increase. Yeah, 2-inch will definitely increase.
Below
Okay.
8 inch, it will be increases. Means the rating will be dramatically changes. So, but
Yes.
after 8 inch, it will be slightly variation you will find. So you have to verify.
Yeah, it depends on the loads also.
Yes.
What I see is up to 4 inch. I mean,
General API loads will also increase, no? 4-inch. Yes.
No, what is actually your query is whether you don't want to increase the ratings or you don't want to verify the derating of that one.
I don't want to increase the rating.
Then you have to request your client that we are not going to verify with the derating requirement. But now, as per now recently, you mandate for U stamp and vessels, and that one you have to compulsory you have to do for this derating verification and that one.
So for use stamp vessels.
Yeah.
no, I mean, actually, if you see, I mean, it is like a good engineering practice.
Yes.
So you have to do it. I mean, so I mean, maybe by experience, I mean, in the field, what happens, nobody knows. Sometimes it works, sometimes it may not work. So, as a good engineering practice, it is better to do it.
Yeah, because your flanges and that it will be safer if you verify with
yes.
the derating and that one. Your flanges will be safer for longer period. Whatever the period you designed for your vessel, it will be
Yeah,
safer for that.
generally, what happens if you don't check properly, I mean, it may lead to leakage. When generally leakage issue will come.
Correct. And this we are doing in order to mitigate the external loads, like piping loads.
Exactly.
Yes.
Am I correct?
Yes.
Okay.
Okay. Any more issues?
Okay. I have the question. I have the similar question on that regard. See, I don't know if you have experienced that, but when we do the UG-44 derating, there are 3 criteria also that needs to be fulfilled if you are doing UG-44. One is the ASME PCC1 requirement. Another is for the bolt. Bolt material should be of higher strength than SA193 of the same size actually.
Yeah.
So in one of our query, our bolt size was greater than what is available in the part D for SA193.
Okay.
Let's just say for one a ballpark figure, for 193 the limitation is for 50 mm dia, and our dia was 60 mm. So AI was asking, how are you going to justify this, whether or not it is meeting the requirement of the code in this statement?
Ramakrishna or Abhishek, did you got the query?
Now, what is the requirement as per code for the bolt diameter?
Oh, okay. It is SA193 bolt, but strength should be greater than SA193 bolt of same diameter.
Strength should be, say,
Greater than or equal to SA193 bolt of same diameter.
93, which grade?
B7.
Okay. So now in your case, what's happening?
So in my case, let's just say 193 B7 was limited to DN50. I'm saying 50 mm diameter.
Okay. So okay.
Yes.
So if you go for higher bolt, your strength is less. That what you are meaning?
No,
One.
the strength that has been provided in the code part D
Correct, yeah.
is only provided till 50 mm diameter for 193B7.
1 minute, let me check what is in the code. Maybe you can, meantime, I'll check maybe somebody, maybe next topic, somebody. If we
Yeah,
have-
but means your issue is the the material which you selected currently, and as per requirement or client specification, you need to select the higher, or as per UG-44, you need to select the higher strength material, right?
I mean, the query
No,
has been resolved.
I got your
Yes,
point, Anshul, that you mean to say that suppose SA 193 D7, it
Yes.
says that tensile strength should be 415 megapascal. Okay?
Okay.
The client is saying that this much should meet the requirement, but my bolt size is M60, while SA 193 says that I am restricted up to only 50 mm diameter of bolt.
Yes. Yes.
Correct. So now we have
Yes.
to go to the select the different material where
Yes.
I think was IS 1367 is there, where you can go with more than 50 mm, and you may need that strength also.
Yes.
So you check IS 1367.
But to change the material and that one, I think you have to first get approval of client and that one, because you're changing
No,
the.
Yeah,
actually,
that he can propose.
Yeah, see, when you're designing as per ASME, foreign metal is not allowed. I mean,
193 B8 class 2 is mentioned, I think, in the UG-44.
yes.
Yeah,
Hello?
but then you have to, in the ASME, what are the material listed? Only that material you have to get.
No. Actually, we are using that material. See, the strength reference is provided for only one material, but there are many other material for bolting also.
Yeah.
Like, for example, there is non-ferrous bolting also. Even in the SS and CS bolting, there are bolting 320, SA320 is there. So there are bolting of different size. We are using the material that is available in the ASME. And actually, we resolve the query while saying that when our strength is greater than SA193 for M20. How do I say this? Let's say for up to the range that the material strength was provided, our bolt has higher strength than the code required bolt.
Okay, then you selected the higher strength
yeah,
bolt already, and
yeah,
it's saying that AI is.
Anshul, I have a. Yeah, I'll check the code. It says S73 grade B8 at the specified bolt size and temperature is talking, no?
Yes,
So
yes.
if you see then you see the specific. If you are 60, why are you comparing with the lower bolt diameter? You 60 equivalent of the 60 mm diameter only check, no?
Yes, sir. That is the question. Na? Ki 60 is not available for one B8, let's say.
Okay. 193 B8 60 is not available.
Yes, it is limited to 50. I mean, I'm just giving a ballpark figure. I don't know the exact, but similar situation was there for our case.
Okay.
So what I gave him as the justification, and he agreed because the job was getting delayed because of that. That for up to which the strength that was present for 193 B8.
Okay.
Our material, the material that we have selected for our current bolt M60, is greater.
Okay.
So there is no point na ki for a higher bolt diameter it will decrease. So
Okay.
I mean, we accepted that, but is there anything other than that we could have done?
Now, I think they have added in this 2023 version, I think. Correct? In the edition. Earlier it
Yes.
was not there.
Yes, yes.
So, I think, yeah.
Yeah, other than that, I think you can make some numbers of bolts and that increase or decrease in that way also you can do. The
I mean, in some cases we are using the standard flanges. Flanges have higher bolt diameter than the
No,
required.
that is not advisable actually.
Yes.
Sometimes code interpretation will be tricky.
Yeah.
Okay,
And
your issue is resolved or it's still?
no, I'm just, I was floating the question out that if you find any other way, then we can
Yeah, we tried with
justify
some
that.
increasing number of bolts in that one, and any other in this group tried any other way, they can
Yes.
answer.
If you find anything, just ping the group regarding that.
Yeah.
Actually, the question I raised on the group regarding the support bracket
Mm-hmm.
warning. Can I share my screen on that?
Yeah, yeah, you can.
So this is visible.
Yeah, yeah.
Yes.
Yeah.
Yes. See, this is the red warning I was talking about.
This one, I think you can ignore this.
Yeah.
You don't.
Actually, we said
Yeah.
that you can ignore that, but you can say it cannot be removed now.
No. It cannot be. Yeah.
Yeah,
It
you
will
cannot
if
remove.
we provide G-loading in the seismic data.
What
Well,
happened?
actually, Atul, I tried providing some random data, but I don't remember if it was removed or not. I'll check and get back to you.
Yeah, in bracket designing, we also used to get this error, but in this one, G loading, if you add, then it may solve your issue.
Yeah, it may solve.
Okay, thank you. Anyone else? Any question?
Any other, Anshul, any other issues?
Just a minute. There is one question I have regarding the consider a tube sheet kind of attachment for a non-heat exchanger vessel. Let's say a vertical vessel with a tube sheet or a filter plate, some might call. How do you verify its thickness?
I mean, what is the material? Material of the tube sheet?
Material is CS. It is being designed in a differential pressure of 3 bar, and the tube sheet is inserted inside the ID of a 2-meter vessel, and it is fillet welded to the vessel.
Yeah, I know. So actually, in my previous experience, we used to. I mean, our company used to make a lot of filter vessels. So
Yes.
I mean that you can design, like an heat exchanger, you can do it.
Okay.
But generally, we used to, based on our experience, we used to keep some thickness. But in some case, I have to use duplex stainless steel tube sheets. So that time we went for FEA.
Okay.
Yeah, because I mean, if it is carbon steel, it's not worth to go to FEA, but that is the best method. Yeah. So
we cannot calculate.
3 bar.
Yes, it's actually there are 17 vessels now, so it's varying from 3 to 5.
3 bar is very high actually.
Yes.
Very high. I think.
Yes, it's a flat plate.
It's a flat plate, huh? I think then in that case go for FEA. Actually, there is you can do one method that you can calculate the thickness as per UG-44 and you can put the ligament efficiency, but that will give a very higher thickness.
Yes, actually, I have checked with one other method of the stress and strain method by Rokes. In there, they have specified uniform loading in a circular plate with a hollow cross section.
But that is at the center, no? Central hole, no?
Yes. So, I mean,
But
some of the vessels have sector holes. Most of the vessels have pigment holes.
Yeah, filter. It is collages. What kind of filter?
Yeah, both are filters and collager both are there.
So generally, collages means you will have bigger holes. No? Yeah, multiple holes.
Yes.
So I mean, if it is 2 meter and if your differential pressure is 3 bar, which is very high, I think you should get definitely around 100 mm, 100 mm, I guess. So better in that case go for FEA.
Okay.
Yes. All are carbon steel. All the filter plates.
30, I guess 30s are carbon steel, 4 is SS and 1 is in color.
Okay.
In color tag is very small, so no issue on that.
I think best method is to, to do the FEA. That is the correct way.
Okay.
Anshul, you have this tube sheet and you want to means check the thickness of that tube sheet, right?
Yes.
So it's
Actually, it is called a filter plate, not tube sheet.
okay. So filter plates, I think.
Filter support grid plate or something like that. They will call it. Yeah.
So it cannot be done as a flat head like that.
It's flathead. I can do.
But it will have what is openings, no?
Yes. The ligament efficiencies I have to provide.
That then in the case it will be very very high.
Yes.
Lig-
2 meter flathead.
Or you try one more method. AD Merkblatt, one code is there.
Concept? Which one?
AD Merkblatter.
It's an AD marklet.
Yeah. So try that in that one B5, I think, I don't remember, but check the B5 part. In that takes actually consider them. I mean, it consider ligament efficiency, but it is somewhat conservative. I mean, it's economical compared to ASME code. You can try that.
Okay.
Yeah. We used to do it for the rectangular tube sheets.
Rectangular.
Yeah.
Okay.
You got it right? AD Merkblatter.
Yes, I've written it.
Yes.
Okay.
Okay.
That's it.
Any
I
more?
had only 3 questions.
Okay. Ramakrishna, do you have any issue?
No, none at that.
Okay.
Yeah. Thank you.
Okay, bye.
Okay.
Good night.
Bye. Good night.